I was at the wedding and the reception, and then a couple of hours later, my best friend's sister, she got married, so we got invited to the house with all the family to have dinner.
That's awesome. That's really wonderful for her.
Yeah. But her last name is now Funk. F-U-N-K. She's now Maddie Funk.
That's kind of cool.
Yeah. We were hoping she would hyphenate her name, keep her last name and just add it, but she's like, no, we're going full Funk. And I'm like, okay, Maddie Funk.
Embracing.
How are you?
I am much better now. Last week was really stressful. I did some project in my horticulture class and made a turn that says if your house across the street. And I didn't know that, so I was checking at the front desk like twice a day, all last week. And then I went to University Mailing Services and they said, no, it's definitely at Bennett. You need to go check. It's been delivered. And on Amazon it says it's been delivered. So I was like, that's actually something. So finally, it was yesterday and I still don't have my seeds. So I skipped my Spanish class and went door to door to find my seeds. And luckily, the second person that I knocked, they were like, it's alive. What's your name? I said,
why wouldn't they just take it over, like,
I don't know.
once a week, be like, or...
Because, like, she had packages back there for people. And when I went on, there was a package. I figured it was just hers. And then she's like, this happened a lot. In fact, I have no idea who this guy is. And I was like, but I guess not be able to see her. So I went over and found my seeds and then the project fixed it and now the stress is gone.
But now you gotta figure out your mailing address. The proper
Just put it in the address to it's fine.
Yeah, you just put in Bennett Hall and room and stuff. It makes no sense, but it's how they do that.
Yeah.
I wish somebody had explained that to me though, because I just ordered the package with like a real address because that makes sense. So it was some unnecessary stress, but I think I'm stronger because of it.
Of course.
I grew.
Did your seeds grow then?
I'm pretty sure those seeds cannot grow. I bought like really, really cheap seeds because I'm just using them for art, so they just have to look right. And so I'm pretty sure they might not even be viable.
That sounds about right.
But they were and peach pits and cherry pits and apple seeds. And I knew I could probably just go eat some of that fruit and get some seeds, but not as many as I needed. So I just ordered them. It's getting pretty close to quest time.
I did debate, like, just watching the live stream.
As stressed as you are, I think that would be permissible.
Well, I'm like, I've been in my dorm all morning. I'm like, I need to get out. I need to get dressed. I need to get out. That'll make me feel a bit better. And then after this, I'm going to go eat. And just comfort down in the library.
This weekend, another thing that helped me de-stress a lot, we had a silent retreat, and it was so nice to just sit there in silence and not do anything or really think about anything and just like exist.
I don't think my brain could handle that. I think it would go, my brain would be all over the place. It would not.
I think if you do silent my thoughts for like an hour, and then after that, I would just like, I would be silent, just like thinking like the entire time.
I just tried to focus on like whatever I was seeing, so like the trees and all the leaves falling down. It was a really still day, so it was just kind of nice to sit there and watch anything happening. I don't really think about it, just look.
What was it for? Church group?
Yeah, the church visit.
All right. Welcome, if you who join us now. Everybody doing okay?
Oh,
You seem stressed?
Yeah.
Anybody else stressed?
Brilliant.
Yeah.
I showed up. That's the first thing.
Yeah, no, I feel it. I think it's that time of the semester where it all starts crunching, and I hate it. I feel it too. All right. Before I start, any questions, comments, concerns, anything at all? Make sure I have my whiteboard marked correctly. Yeah, if you get no room on that. All right. Nothing? We're good? We're good to start blabbing at you about this stuff?
Yeah, my mind's too fried to think of questions.
Okay. I feel like my mind's too fried to lecture right now, but I'm going to do it anyway. I slept past all my alarms and woke up feeling just like absolutely insane today. So you'll have to bear with me too a little bit. Nothing though? We good? Okay, so let's just pick up where we left off. Where did we leave off? We covered the process of inquiry. Does somebody want to recite that for me?
You start with observations.
Observation or experience. Good. And that leads to?
Questions.
Skipping a step.
Puzzling event.
Puzzling event. Yeah, puzzling observation or something. Puzzling event or observation idea, whatever. Right? Puzzling experience. What about after that? Then we get into question asking. What is this called? Questioning. And then what about from there? Theorization, or I'll call it the proliferation of hypotheses. Now I know that last time I put this in its own separate little category, but I rethought that. And I've revised this little reading. If anybody wants it, I included a chart like this in it. I'll email out that chart. If anybody wants to see a revised reading, just let me know. I'll send it to you. Proliferation hypotheses, which is also called theorization, right? Because when your hypotheses are proliferating, you're coming up with all these different theories, right? So that's just one step. And then after that, what happens after proliferation or theorization?
Testing and confirmation or disconfirmation.
Testing. I'm going to do this. I'm going to put a big circle to indicate that this is really one thing. I'm going to call this whole thing inference to the best explanation. And now, I've already kind of talked about this a little bit, and we'll get into it more, I believe, the week after Thanksgiving. But IBE isn't just a type of argument, it's an entire process, right? So within this process, we have testing, which is also called confirmation and disconfirmation. And then you also have the more narrow conception of IBE, which is a particular kind of argument. Don't get too hung up on this. See this really as just one big lump. That includes testing, but it also includes some other concerns like Occam's razor, right? But really that all falls within the process of trying to find the best explanation, right? Okay, what about after that? Yeah, a tentative conclusion. What makes that conclusion tentative? What do I mean by tentative?
Not permanent.
Not permanent?
Because
Yeah.
you're always doing this over and over and over.
Right, so what is the goal of inference to best explanation? What does it mean so far to say we found the best explanation? Does that mean the best explanation of all time? Out of the ones we have, given the evidence we currently have. And so, yeah, of course, that tentative conclusion will then need to be revised by looking for more evidence, coming up with more theories, and you just go forever, right? Okay. Any questions on this?
I have a question. What does it mean for data to obtain?
Okay, so this is something that I've purposely kept vague and obscure for data to obtain. And there's complicated reasons for this that I don't really know what to make of. when we talk about like our deductive logic, right, what have we been dealing with all semester? What's the subject of deductive logic? Of this kind. What's the kind of deductive logic we've been learning?
Symbolic logic.
Symbolic, well, there's multiple kinds. What kind of symbolic logic? That's the proof method, right? But what's the language we have learned called? Starts with a P. Propositional. The subject matter of the logic we've learned, deductive logic, is propositions. Those aren't events. Those aren't people. Those aren't entities. They're whole propositions. Right? So when I say obtain, like some data obtains, this is super vague because I want it to include this proposition P is true, or this event E happens or occurs. Now, on the one hand, you can talk about events within propositions. Whenever we talk about event, we're using propositions, right? But they are separate things, right? Talking on the level of events and objects and talking on the level of, whole propositions are a little bit different. So when I say data obtains, I mean the data could be a proposition that we know is true or false. It obtains, or an event, right? An event obtains and that event occurs, it takes place or it doesn't take place. Or we can talk about even objects doing actions, right? Like A does action phi. Now this whole thing is an event itself, right? And then the proposition describes that entire event. So I'm not really sure exactly what to make of the different relationships there, so I want to keep it super vague, right? Does that make sense?
In as much as it's vague, yes.
Yes.
Makes sense.
Allow yourself, what I am doing here and what at the very theoretical level philosophers are doing is a lot like what scientists are doing. Scientists are modeling the universe, modeling the physical world. They do not get everything completely exactly right? They can use broad brushstrokes. And sometimes when you make a model like this, you have to know kind of when to say, I have no idea the details, right? So keep it kind of vague. So yeah, just keep in mind it could be a proposition obtaining, it could be an event happening, etc. Right? Okay. Any other questions on this or anything related? Okay, so what are the two types of theory again?
Explanation and prediction.
Explanation or explanatory theories and predictions. Okay, so we've got this whole process, obviously within here we've got that. But let's start talking about, I've already kind of previewed it last time, but the structure of an explanation and the structure of a prediction. And then let's talk about testing or confirmation, disconfirmation, which I kind of previewed at the last part of class, but I want to get into more detail. Make sense what we're doing? I'm going to stop a lot and ask, make sense what we're doing, because this is really easy to get caught up in. It might look like a simple model, but it's really complicated. And for instance, if you go and you look up philosophical literature on inference is the best explanation, you're going to be dealing with, let's just say, IBE as a definite type of deductive argument. Philosophers have not really been giving much attention to inference is the best explanation as a process. So just here, 60 years of literature can get caught up on this. And it's only in the last 20 years that you start going back to more holistic conceptions, right? So very complicated. Okay, so bear with me as I inevitably keep checking on you to see if you're lost. And if anytime you are lost, please ask me a question, because I'm about to put something really complicated on the board. Really, really lengthy, too, that I don't want to write out. Okay, starting from the bottom up, the simplest level of explaining this. We have testing, or disconfirmation and confirmation. We then have the structure of explanation and prediction that I want to cover today. Again, I know I covered last time, what's the general structure of an explanation? What's it made out of? Explanans. I'm going to say my explanans, I'm going to number them E1, E2, although that's going to be problematic later, so just bear with me. Here's my explanans, and then what do these do?
Give reasons for.
They give reasons for what? The explanandum, but what type of reasons? Reasons to believe it? Reasons why. Good, right. Reasons why the explanandum occurs. Good. Okay, so let's say if you've done the reading, you've seen this thought experiment. My OCD is going to bother me if I leave that smudge. Explanandum. There we go. You've seen a thought experiment of, okay, there's a strange animal or something or someone in my neighborhood killing all these birds at night. And so I walk out, and for the last 2 weeks or so, I'm noticing just a bunch of dead birds everywhere. And if you've ever seen a bunch of dead birds, you'll know that things don't normally eat the bird's wings. They eat everything else. And then they leave the tail and the wings, and there's no meat on them. It's like bone and cartilage and feathers. So I'm just going out and I'm seeing like a bunch of feathers all over the neighborhood with just like ripped off bird wings and tails everywhere, right? And I ask myself, what explains this puzzling event, right? So what's my explanandum here?
Bird wings and tails.
Okay, the explanandum. Let's just say I've noticed, we'll just say an uptick in dead birds in my neighborhood, right? I'm finding them more often. Of course, if you look hard enough, you'll see this in every neighborhood where the birds exist. Fine. But there's an uptick. It's becoming an epidemic. And I'm like, what the hell is going on? I love birds. I want to stop whatever's killing them. So I come up with some theories. What's one of the theories I mentioned in the reading? That a cat is killing them. Okay. Or multiple cats, maybe. Whatever I want to say. How can I kind of fill out the explanation to put in that story? And remember, these taken together are the entire hypothesis. I don't know why I keep writing H like that. Hypothesis or theory or story. And now I want to break it into parts and kind of model it like this. How would I do that?
So I guess you could say you know that cats like to kill birds.
Okay, yeah. So we could say something like cats often kill and eat birds. Okay, so there's some background information. Maybe I can make that statistical. I don't know. All right, so there's background. What else? What are the other parts of the story?
An old lady moved in next door with 10 cats.
Okay, sure. So let's say that more cats have come to the neighborhood lately, right? And I'll leave the old lady information just kind of as more background. We just say there's more cats here lately. Now let's just say we don't know that that's the case. Again, these are posits. If we knew what explained this, then why would we need to do all this stuff, right? If we already knew the answer. So the parts of the story are hypothetical posits. We're saying, well, maybe this is the case. And if these things were the case, then it would explain this, right? Okay, so our explanation so far, cats often kill and eat birds. Second part of the story, more cats have come to the neighborhood lately. And then we can maybe say the third part of the story, something like cats in neighborhood are killing birds at an alarming, well, let's say at, what the hell? What a weird thing. This like just does not work as an eraser. Very strange. And now it's made it worse. Oh. I think increase rate. What did you say now?
It's a indelible marker.
Yeah. Wow, that's bad. Okay. So that's the whole story. We can add more details. But the point is basically it boils down to, look, it's cats eating all these birds. Right? The unknown animal that I'm not really sure is happening is a cat. Right? I could break this apart in different ways. I can model the explanation different ways. It doesn't matter that much. Right? I can even just erase this whole thing and say, there is a new cat or multiple new cats in the neighborhood, and that's what explains this, right? Okay, so we've got the posits, all part of the hypothesis. That's the rough structure of explanation. And what this arrow means, whenever you see this double-pronged arrow, it means that it has reasons relevance, and it means that it has statistical relevance to the explanandum. Hopefully we've read the packet because this is pretty complicated. And I'm not going to give you like a full rundown on this. But essentially what I suggest, and what a lot of other people suggest, the nature of explanation is that some story or set of facts tells you the reasons why it happens, right? It's relevant, explanatorily relevant, reasons relevant, right? Make sense? Okay. Then the other part is that it's statistically relevant. And what is that? Does somebody remember from the reading what I mean by statistically relevant?
That like the posit makes it more probable. Like makes the explanation more probable.
Good. Let's just say the hypothesis, H, increases the probability of the explanandum E. Right? I'll do that. Explanandum E. Okay, so what does that mean? It doesn't mean that it makes it super probable. It just means that, well, a good explanation is going to do two things. On the one hand, the first prong, it's going to tell us, at least hopefully, some of the reasons why this is occurring. Right? Is this reasons relevant? Is this story reasons relevant?
Yeah.
It tells us, like, right, the cats, the positive cats, we're not sure if they exist. But if they did exist, yeah, that would have some sort of causal or reasons relevant to the explanandum. Relevance. Okay, what about statistical relevance? If this story was true, right, if more cats have come to the neighborhood lately, and cats in the neighborhood are killing birds at an increased rate, if that was true, wouldn't it raise the probability of the explanandum that I'd find more dead birds? Right. It doesn't have to make it guaranteed. It doesn't have to make it 80% probable. It just needs to raise it a little bit. Because if this was the real cause of this, if the cats were the real cause of the birds, it would be kind of weird to say, yeah, that's the cause of them, but it actually doesn't affect the probability that the birds are going to get killed by the cats. Even though the cats are the things killing the birds. I don't know if that makes sense. Read the packet. Okay, so the two things, again, an explanation, each of these prongs of the arrow represents its, at least potentially reasons relevant, tells you the real reasons or causes why. And this one is statistically relevant. The hypothesis, if it was true, would increase the probability of the explanandum. Questions?
How do E3 and the explanandum, how are they exactly different? It feels like they're saying pretty much the same thing.
Right. So they're saying something very close, but this is the posit. I'm saying, look, the cats in the neighborhood are killing birds at an increased rate. Now, the explanandum is that I'm finding dead birds. Not that cats are killing them, right? The cats killing them are why I'm finding the bodies. Does that make sense? It's hard
It's
to
just that
divide.
detail.
Right. Yeah, it's attention to detail. It is really hard to give a theory of explanation that includes all the possible ways we can do it. Like I said, there are different ways of slicing up the story. right? And relating it to this. There's even different ways from divide. Sometimes it's not clear what's the explanandum and what's the exponent, because sometimes they can meld together. And you get that especially as you get more and more into theory, and abstract theory. Does that make sense, though?
Yes, I think so.
Alright, so that's the structure of explanation, and that's what the arrow means. Let's look at the structure of prediction real quick and why it's different. Let's just say we have data, or testing bit. Data 1, data 2, data 3. What's that line?
The conclusion.
The conclusion, the inference line, right? So it's that anything above this is the basis on which we infer something below this, right? So let's just say, we won't use the cat example, we'll just use something else. Prediction. Who wants to come up with a prediction?
Anything?
What?
Just anything?
Anything, yeah.
How about my prediction is that I'll do well on my final?
You'll do well on your final. So I will do well on my final. What's the data or the grounds that you predict that on?
Well, I've been studying.
Okay, so I've been studying. What else?
Slip the teacher some cash.
Okay, I bribed the teacher. What else?
I'm good at cheating.
Okay. I'm good at cheating, or I'll just say BSing to include the other forms of BSing. Right? Okay. What else?
Maybe the final is reportedly easy.
I have found the answer to this.
So before final is rumored to be easy. Good luck with that. B5, what else?
I paid attention in class.
Sure. I have been paying attention in class. Now, we'll just end that there. We could also add something else about maybe some statistics on if students study well, then they have this probability of doing good on the test, or if they've been paying attention and study, you know what I mean, like statistical data about correlations between studying, bribing, BSing, and success, right? But we can just leave that out, because we don't really, one, how would we ever get those statistics? I don't think you could do something like that, because the tests for each teacher would change, right? They'd have to be standardized. But otherwise, you just also don't need it, right? Because this is, again, not a deductive argument. This is an inductive argument for the conclusion. I will do good, whatever good means, on the final.
We could also say that my definition of good is like a 60%.
Yeah, right. Especially if, your definition of good is low bar, right? Then it's like, oh, as long as I pass, I'm doing good. Yeah. Which, that makes it even stronger, right? But you can see this is a justified inductive inference. This data makes this probable, right? Okay, that's prediction. Does this tell you the reasons why this is probable or true? It might, because you've been studying and all that. Does it have to, though? Do predictions have to tell you the reasons why? No. Because again, look, this is just an argument, an inductive argument. It establishes, so prediction tries to establish a conclusion as probable or as expected. So this has to, at the end of the day, raise the probability of the conclusion above 50%. And here I think, let's just say, it's bad to say it would. But again, when we look at an explanation and we have statistical relevance, that doesn't have to raise it above 50%, right? It just has to raise it a little bit. Here's an example. that are erasing things. Did I do this last time about the penny?
I don't think so.
Okay, so let's look at an explanation. My puzzling event is just that I got tails and not heads. Now, why that puzzles us is because we know that we have a rigged penny. We have a slightly bent penny that 90% of the time, so let's say penny P has a bias towards heads, and we'll just say 90% bias, which means 90% of the time, 9 out of 10 times, it's going to land heads, right? E2, I threw the penny, and then that explains, oh, I got tails and not heads. How does that explain?
Because the E1, if you wrote it out a different way, it would say the penny has a 10% chance of landing tails, and that because it makes it more probable, it makes it more probable, not necessarily like the most probable or more than 50%, it's still more probable than not.
Okay, good, right. So these two explanations, the hypothesis taken together as a whole, does one thing. First, what you said, its reasons relevant, right? It tells you the reasons because it tells you about the constitution of the penny and what's possible. That, yeah, there's a small possibility of it landing heads. The penny has this nature, this shape, this bias, and so it tells you exactly what can happen if you threw it. Then it also tells you the reasons why it had an outcome at all. You threw the penny, right? So these tell you together reasons why this happened. Reasons relevant. Check that off. Okay, but what about statistical relevance? You also said it was statistically relevant. How?
Because if you rewrote E1, you can say the penny P has, let's say, a 10% chance of landing tails.
Good. Has 10% chance of tails if thrown. Now that you couldn't use this as a good prediction, right? Because it would end up being, if I predicted I'm going to get tails, you'd be like, what are you talking about? It's only a 10% chance. That's not a good prediction. You're not establishing anything with probability or confidence. But it does tell you something about the explanandum because it's reasons relevant, and when you take these together, what's the odds that it comes out tails if you don't throw it? 0, right? So just the fact that you threw the penny and that it was a small possibility of being tails raises the probability ever so slightly that you're actually going to get the tails result. So it's also statistically relevant. Right? Does that make sense? Again, this is something that people have just, since the 1970s, been really realizing how different explanation and prediction are. So again, this explanation does not have to make this probable. And if you read the packet, if you read the little book chapter I gave you, the most influential theory of explanation basically collapsed explanation to prediction. The Hempelian model, where explanations were basically just predictions. It's just not true. I just gave you a perfect example of an explanation that's not a prediction, right? That doesn't make its explanation probable. Okay, so here's one difference between these two, explanation and prediction. Explanation need not make explanandum above 50% probability. All it has to do is has statistical relevance and reason relevance. Okay, here's another difference, right? Prediction need not have reasons relevance. Why is that the case? This prediction does have reasons relevance. It tells you why you're going to do good. Because you studied, you bribed me, etc. But if I were to slightly change, actually, if I were to come up with a whole new example, I could show you that with this prediction. Let's say 1. Weatherman on K4 says, did I spell K4? the Weather Channel
Yeah.
here? Right? Weatherman Antifa says it will rain today. 2, Weatherman, or Weatherwoman, I'm sorry, on, what's the other news station here?
Channel 9.
On Channel 9 says it will rain, right? Conclusion. It will rain today. Again, I don't mean this as a deductive guarantee. It's clearly not a deductive argument. But if 2 weathermen, or women, sorry, at different stations tell you the same thing, doesn't that make it likely they're probably right? Testimony, believing testimony in a court of law, or just what we say to each other, falls under prediction, right? Do these tell you the reasons why this happens? Is it going to rain because the weatherman said it? No, right? Does it increase the probability? Good, yeah, so prediction need not have reasons relevant. So it doesn't have to tell you the reasons why. The other difference is prediction must, in order to be a good, successful prediction, make conclusion above 50% probable. Okay. Make sense? If something's 50% probable, what is that? What's it mean? As likely as not. It's even, right? Did you have a question?
Yes. Okay, so if both weathermen said there was like a 20% chance of rain, then how would you, does that combine? Or
So you're thinking of weatherman one says 20%, he says 20%, so really it's 40%. No, that doesn't make sense, right? Because like it's not like they're saying this data makes it 20% more probable, this data makes it 20%. It's just saying their guesses are overall 20%. So really you probably just say, well, that gives me pretty good evidence for thinking it's 20% probable. Complicated question though. There's all sorts of these weird little mysteries here that are very, very, very complicated. And I'm just, every day I continue to work on this project, I'm just like more and more baffled by what the fuck is going on. Like seriously, this stuff gets so, it's not even necessarily overly complex. Some of the stuff using the mathematical language and models that people do is stupidly complex and like just doesn't have to be. But the actual theory of what's going on here, psychologically and logically, is just, it's stunning. And I'll save that for the last section. Okay, so that's the difference between prediction and explanation. Predictions are arguments, but they don't have to tell you reasons why. They can, it helps. Explanations aren't arguments, or aren't necessarily arguments, right? If I give you an explanation, sometimes a really good explanation is going to make this explanation more probable than not, right? In that case, it's also a prediction. Make sense? There's a conceptual overlap here. Okay. So we kind of get the structure and nature of explanation and prediction. Let's go into testing. And let's call this hypothesis 1, 2. We'll call this hypothesis 1. So testing or confirmation and disconfirmation comes after we proliferate a bunch of hypotheses and then we're checking to see which ones got the most evidence for or against it. Which ones can we rule out, right? How does testing proceed? How does testing work? You've probably heard it called experimentation if you've read an intro to science book, and that's just wrong. Experimentation is one kind of testing, but doesn't that make you think of like a scientist in a lab coat, like screwing around with beakers or something, right? Just not. Testing like that type of experimental lab or field testing is just one sort of testing. This is a broad category. Like physicists don't normally test like in a lab with a lab coat. Maybe if they're doing stuff with like, like particle physics and trying to send like, a electron or whatever through the colliders. And I don't know enough about that shit. Anyway, So how does testing from the reading proceed? How does it work? What's the normal way of testing something?
Just like gather more data and like test that data against your hypothesis to see if it holds up.
Okay, so once you have your hypotheses, you gather more data, right? And you try to see how that data lines up with the hypothesis, but just any data? So if I have this hypothesis about the birds and the cats, do I go out to, I don't know, like a different country and start collecting data there? Would that be relevant? No, so what type of data am I looking for? How do I know whether the data is relevant?
Data that would confirm or disconfirm the specific things you already posited.
The data is relevant when the data we're going to collect is going to have some sort of probabilistic or evidential impact on the actual stories. Well, how do I know if it has impact on the stories? What type of data am I looking for that impacts the stories?
You're maybe going to look to be disconfirming stuff, right?
Say that again.
You're going to be disconfirming stuff mostly.
You can also confirm it. Yeah, there's both positive and negative. Yeah. But like, what type of stuff would help me do that? If you remember from the reading, or just in general.
Oh, there was like I remember there was a list. So it's like statistical relevance, and then it's at the thing at the beginning of section 2, isn't it?
Yeah, it's the beginning of that section 2. Yeah. So here's what it is. There's plenty of data that's just completely irrelevant. It's not going to help me test anything. The data that I'm looking for will be essentially data about predictions. It will be, if H2 is true, then that would imply something else being true. Or if H2 is true, then that makes this something else probable, right? And I look around, I draw out predictions from my theories and stories saying, if they were true, what would follow? If they were true, what would be probable? And then I look for that data in particular. Does that make sense? Okay, so tell me, what are some predictions that hypothesis 2 makes? If hypothesis 2 is true, if this story happened, as I describe it here, what else would I expect to find or to be true? It doesn't have to be guaranteed, but, you know, just...
You probably see some cats around the neighborhood you looked around.
Okay, so predictions from H2. I'd probably see some cats. If I looked hard enough, right? Okay, another prediction. Let's think of some more.
There's going to be some feral kittens.
Okay, I'll probably see cats. I'll probably see kittens. If they're really reproducing at this rate, that would explain why they're killing all these birds, right? Something like that. Okay, what other prediction? If H2 is true, what else would I expect to be true?
You could also expect like the birds are probably smaller birds, like not like birds of prey and stuff, and they might have like scratch marks or side marks on them that may come from a cat.
The bird carcasses will be smaller because, of course, unless it's a big cat like a mountain lion or a lynx or something, or a bobcat, they're not going to be eating a hawk, right? In fact, hawks eat small cats, right, and dogs. They're the predators there. So bird carcasses will be smaller if the cat story is true. Good. Then we could also say bird carcasses will, let's just say, have teeth marks and claw marks. Let's just say it's a hawk killing all these birds, or an owl, which is another hypothesis I want to entertain in a second. Will those have teeth mark on the carcasses? Why?
Because they have beaks.
Yeah, owls and hawks don't have teeth, right? So if it was cats, we would expect some teeth marks. if we find any remains. That's the thing. Like I mentioned at the start of this, if this actually happens, which it did in my neighborhood last year, you never actually see the bird. You'll walk outside and there's just an entire wing. And they're just sitting next to each other. Like something came up, deleted the middle of the bird, and just left two wings. It's crazy. And then we found that it was eventually a cat, by the way. And I found that cat, and it decided to live in our backyard and terrorize our dogs. It was a feral cat. And we fed it. It was a very sweet cat. Hated dogs, hated birds. And it was completely subsisting on sparrows. It was crazy. Yeah, I don't know. It's weird. There's a lot of feral cats in Stillwater. Anyway. Okay, so let's go with some of these predictions. Anybody have some more you want to add?
You might see the tufts of cat fur if the birds bite back.
Okay, so we'll find cat fur strewn around. What were you going to say, Sophia?
There's going to be like less rodents, like less mice.
Okay, we'll also find less rodents around. If I look again, there's no guarantee that I'm actually going to be able to verify any of these things, right? Okay, one more. Give me one more.
You might overhear a neighbor mentioning how they're spending so much less on cat food.
Oh, okay, yeah. I don't know if I would say that's a prediction that if the theory is true, a neighbor must have lost a cat, right? Maybe it's just a feral cat that came in, or multiple.
Oh, but the cats are getting full.
Say that again?
The cats are getting full on bird.
The
Or
cats are getting full on
fat.
bird.
Oh yeah, maybe
Cats
cats
are
are getting
getting
fat.
Would this story being true make it above 50% that the cats are full and fat? That's a possibility that might happen, but I don't know if I would say it's a real prediction, right, of the theory. Give me something with your ears. I may hear cats. What may I hear?
Meowing the birds.
Or distressed birds.
Okay, so I might, if I look hard enough, or if I listen at the right times, maybe it's night, maybe it's early morning, I don't know yet, I will, or I may hear meowing or other cat-like noises, right? Okay, so there's a set of predictions, and the point of what we're doing is we're looking at a hypothesis and we're drawing out, if the hypothesis is true, what else would be true? Then we look around to see, are any of these true? I know I wrote it kind of crooked, sorry. Okay. Let's go with one more hypothesis. What? It's a person doing it. Okay, I like that one. E1. How would I start to model this? I'm going to just put explanandum. It's the same exact thing. I'm finding a bunch of bird carcasses, but I won't write it all out. How can I start modeling this, breaking it into parts?
Crazy new neighbor moved in.
Say that again?
A crazy new neighbor moved into the neighborhood.
Okay, so new neighbor moved in. We can even just say we know that. We'll say maybe, and they are quite odd. We're not saying they're crazy, but they kind of give us a weird vibe. What else?
You keep finding BB gun pellets.
Okay, so let's just say part of my data is that I have found BBs around the neighborhood. All right. How else do we fill in the gaps? What do I have to posit to connect this guy to the explanandum? I have to posit something to connect them, right?
I have found boot prints near where I found dead birds.
You found what? Poop prints?
Boot prints.
Boot prints. Okay, like poop prints. So I was like, what the fuck's the poop print? Around bird carcasses. Actually, let's leave this for a prediction and then look around. See, do you see what I mean of how hard it is to, like, in real life, in the real world, you don't have the privilege of just making up the events, right? So it's much more straightforward exactly what's going to be your explanans. But yeah, let's say that's something we discover after, maybe, for prediction. What else would this story involve?
The new neighbor makes a famous bird stew.
Okay, so I found people in a neighborhood. Let's just say, maybe, again, these are posits. I don't have to necessarily know all of them. They could just be hypothetical posits that I'm saying, maybe this is the story, right? So maybe neighbor wants bird stew for whatever reason. And then E4, we can just kind of conclude and say, I'm positing that the neighbor is killing birds with a BB gun to eat them or something, right? We actually get take out the BB thing too. We're going to use that as data. Okay, so we got, look, a new neighbor moved in, they're quite odd. Maybe the neighbor wants bird stew, right? Maybe that's part of the story, I don't know. Neighbors killing birds with a BB gun. Maybe to make the stew, right? Hypothetical story, kind of ridiculous, but maybe it's true. The predictions of this, they would be, one, I would find human shoe prints near bird carcasses. Two, I would maybe find BBs around or evidence they're shooting them. Because it takes more than just one. You have to shoot quite a few. Do I think it's going to go pick them up? Probably not. What other predictions could come from this? If this story was true, what might else be true?
You should also hear the gun.
You hear the gun.
Yeah, that's
Well,
what
you
I said.
can, some, like a BB gun powerful enough to kill a bird will make a crack. It'll go like, right? You might hear it. We'll just say it's a very small chance. Maybe I'll hear the gun go off, right? The BB gun. Maybe. Okay. What else?
You probably won't find like new bird carcasses while the neighbor is like at work or away or something.
Okay, yeah, so
Maybe you routinely find them.
Oh yeah, maybe you'll find more birds at the during the hours like your neighbor is home.
okay, yeah, so bird carcasses increase during neighbor's time off, right? If I could correlate the neighbor being home and not at work and finding more bird carcasses, then that would be a pretty good piece of evidence, right? Yeah. Okay. Someone give me another one.
The neighbor might bring bird stew to a potluck.
Okay, yeah, so we could maybe ask or maybe predict that someone will have heard about his bird stew, right? But again, maybe this guy's weird and kind of like a hermit, doesn't talk to anyone, so it's just for him. So I don't know if that's a real prediction. We could say maybe. Very small chance, right? Okay, here's another one. Again, my prediction. I say two things. Look, if I ask him if he's doing this, if he's killing them, he will, if he's a normal, honest person, probably just tell you, yeah, I am killing them, right? He will admit it. Maybe just a misunderstanding, is not that weird, he's like hunting birds and eating them. I guess I can't blame him. If I ask him if he's killing birds, he'll admit it, right? And, well, I say, or he will show signs of discomfort. Right? Okay, so if I asked him and he's really the one doing it, if that story's true, then he's either going to admit it if he's honest, and if he's not honest and has some reason to hide it, he might get a little uncomfortable. Right? So that's how the prediction will work. Okay, cool. Let's do one more hypothesis. We'll make it about an owl. So let's just say, again, this is a hypothetical posit. I don't necessarily know this. An owl has come to the neighborhood. 2, owls like to eat smaller birds. 3, this owl is killing more birds. Well, let's just say this owl is killing many birds more than before the owl came. Right? Okay. Now, obviously, that would explain, at least partially, the explanandum, right? Okay. Let's draw some predictions of this. Hypothesis 3. What are some predictions?
Find owl pellets with small bird bones.
I was trying to get my Monday, Wednesday, Friday online section to give me predictions for this one. No one could come up with any. I was like, you guys never heard of owl pellets or anything? Nothing?
Like, I remember dissecting them.
Yeah. When I told them, well, you normally find owl pellets around where owls have been, they're like, what's that? I was like, well, they regurgitate like a hairball, except it has bones in it. And I was like, they're like, what? And I was like, I just used to pick them up and take little nice skulls out. I thought it was so cool. And they're like, you would touch that? I was like, it's not that gross. You just live in Oklahoma. Come on, there's a ton of wildlife here. So let's just say we would find owl pellets in the neighborhood. What would be in those owl pellets? Because they can't digest bones. What would be in those pellets? Those pellets will contain, let's just say, bird bones, maybe a skull, maybe a beak, maybe a talon, whatever. All right, give me some more predictions for the owl.
You might hear some hooting at night.
Good. I will, at night, I may hear hooting. Now that's, again, I'm not saying I will, I'm saying I may, because maybe the owl isn't close enough to my house. Maybe it's a smaller owl and it doesn't hoot very loud, so I can hear it, right? So yeah, that's a good prediction, but not necessarily guaranteed. What else? Give me 2 more. Let's get 2 more for the owl.
You may find owl feathers near the bird carcasses.
Okay, let's just say I'm going to find maybe some owl feathers. And specifically, I guess, near carcasses, because maybe there's a struggle. What else?
Find more carcasses after nighttime.
Okay, yeah, so given that if it's an owl that hunts mostly at night, I will find more carcasses. Let's give a specific time. More carcasses between 12 a.m. to 3 a.m. Actually 4 a.m. Because some owls hunt in the early morning, some owls hunt earlier in the day, or earlier in the night, right? So let's just say I'm going to find it between 12 and 4. I don't know the exact time, but obviously I'm not a biologist. But I'll find more carcasses between 12 and 4 a.m. And I'll also find fewer new carcasses after those hours, right? And that would be a pretty good indicator that that's an owl doing it, right? Do you see how the predictions we're drawing out? That I'm already saying, if I found that to be true, it would be pretty good evidence. Right? Predictions, this whole explanation, argumentation, evidence, and data, it's so complicated because you can't just model it in a line, linear, like a deductive argument. Because your predictions are your evidence, and your evidence are your predictions, and there's a back and forth motion between all of these things, and there's a big circular process of inquiry, right, of method. So it's not as simple as just saying, well, there's the evidence, and here's my predictions, and here's my data, they're all different things. Evidence is a role or the function of data. Data becomes evidence when it has some relationship to a theory or prediction, right? Does that make sense? So evidence isn't a thing, evidence is a role that data can play. Okay, so now let's take it a step further. I come up with these three theories, right? And I go out and I say, okay, I'm gonna look for this animal, I'm gonna try to find it, I gotta stop this bird murder, this bird genocide. And I go out, let's say I go out at 8 a.m. and I'm looking around. I don't see anything, I don't hear anything. I don't see any cats, I don't see any owls, I don't see anything at all. I don't see my weird neighbor, nothing. Is that relevant? Why not?
So it either confirms or disconfirms things.
Yeah, it doesn't really, fall, this chair. It doesn't really have much to do with any of my predictions, right? Because if it was the owl, I'm not going to really find much at 8 a.m. If it was the cats, I'm probably not going to find much at 8 a.m. either, right? They're probably going to be active maybe in the afternoon, but more likely at night, right? If it was the guy, he's probably not going to be active at 8 a.m. either, because he's probably sleeping, or maybe he is at work or something. Let's just assume he's at work. Okay, so, I look around, I don't really find anything useful. What do I need to do?
Keep looking.
Keep looking. Now, later? What should I look for?
Well, you can look around, and like the hour specify for the owl.
Okay, so let's say I'm going to come back at 12 a.m. I'm going to sit outside with my little night vision goggles. I'm going to look around for this friggin' owl to see if it's really there. I sit outside, right, at 11:59, it turns 12. I'm listening, I'm looking around, and I don't hear any hooting. What's that do to this hypothesis? Okay, so let's just say, it's so hard to write all this up and get it all at once. Let's say that some of the data I'm finding is I've got no hooting at 12 a.m. to 4 a.m. Does that rule out the hypothesis that's the owl? No. What does it do? It makes it less likely. This theory, if it was true, predicted that there's a small increased chance that I'll hear hooting, right? Well, I didn't hear hooting. So it kind of lowers the probability, but it's not a knockout argument. It doesn't even lower it that much, right? It just slightly lowers the probability of H3. I'm going to write P parentheses H3, probability of H3, right? Lowers it down here. Or it gives it a degree of disconfirmation, right? Again, not very much. Okay. Let's say I'm looking around at my night vision and I see in a tree, I see an owl. And it's sitting in the tree. What's that do?
It raises the probability.
It raises the probability, right? So it gives some boost or degree of confirmation to my owl hypothesis. Does it guarantee it?
No.
It guarantees there's an owl. Is that the owl that's been killing them every other night? Was there even an owl killing them every other night? No. Does it raise the probability? Of course, yeah, it offers some correlation. It does not give you certainty. You can't use it like a deductive argument, right? What fallacy would that be? Let's say H3 implies that there will be an owl around. There's an owl around. Therefore, H3 is that a good argument? No, why not? Affirming the consequent, right? Good. But it does raise the probability. Okay, so let's say I now look around and I find owl pellet. I find an owl pellet, but in it is a cat skull of a kitten. What's that tell you? So, say it again.
I would say it lowers the likelihood of H3.
Why does this lower the likelihood?
Because you would expect to find bird bones.
Well, I expect to find bird bones, but I did find an owl pellet. Right? That's a confirmed prediction.
But we're not looking for cat owls.
Right, we're not looking for cats. But doesn't that tell you that that piece of data does indicate that there's an owl presence here?
It also
indicate an owl presence, right?
What?
Wouldn't the owl also indicate an owl presence?
Right, but they're two independent. So the owl indicates an owl presence right now. Maybe in the past, we know there's owls here. But the pellet is from earlier, right? That takes time to digest. This owl's been here a while. Doesn't that raise the probability? You see, you have to creatively think like this. It's amazing that philosophers have not figured out a single method for all of this stuff, or a model, like a deductive logic class, and yet scientists and all of us can do this pretty reliably, right? So it's crazy. Okay, so we find the owl. So I'm going to say finding the owl pellet means that the owl's there earlier, and that's a successful prediction that this theory made. Yeah, we don't find the birds, but it's the absence of evidence of absence? Sometimes it can be. If something tells me, if this is true, then this thing will have to be present. And I'm like, but it's not present. Therefore, that thing's not true. So, evidence of absence absence of evidence can be evidence of absence, but not always. It's very complicated. Does that make sense?
Can the finding the pellet also be an indicator of hypothesis too, though?
Yeah, exactly. That's what I was looking for. How does it help you with the cat story?
Because we have the prediction that if cats are eating the birds, there's going to be more feral kittens, and if you find a kitten skull, that means that there was at one point at least one kitten.
Good. It also raises the probability of the cat hypothesis, because now we know that there are cats in the area. Maybe we ask our neighbors, have you lost a cat recently? Have you lost a kitten? And they say no, none of them say that they have. Oh, okay, that must not be a cat from neighbors. That must be a feral cat, right? That indicates the presence of feral cat that boosts H2. So one piece of data can act, remember I'm saying act as evidence for two theories at once. Okay, good. Now, I'm looking around and it's about to turn 3 a.m. where all the spooky shit happens. It's about to turn 3 a.m. and with my night vision, I'm sitting in a bush next to my house. I'm like this in the bush, and I see my neighbor come out. And he has what looks like a BB gun, but it's really shadowy, so I can't tell. I'm like, oh my god, this thing must be correct. And I watch him. And he takes this big, long thing, looks like a BB gun, and then he starts sweeping his porch at 3 a.m. It's just a bird.
Well, that confirms the weird part.
Yeah.
It confirms the weird part. Does that increase the probability? So let's say 3 a.m., neighbor being weird. Does that increase or decrease or do anything for the probability of this?
No.
Why not?
Stay the same, wouldn't
It was part of the explanations, not the prediction.
Well, but so if he is weird, or maybe it might just, that, again, I might not know he's weird. weird. It could just be like, maybe this new guy's weird. I don't actually know, but maybe he is. So I would think that this would in some way slightly raise the probability, like, this guy's behavior is a little fishy, and he moved in at the same time these birds were starting to die, right? I think it raises just very slightly the probability of H1. Okay. But now he walks to his car, and I get my night vision scope, I'm like, I zoom in, I see him get into his little Subaru. I'm like, Subaru, that's kind of a trendy, cool liberal car for this guy. And I'm like, oh my gosh, what's this bumper sticker? And I put a bumper sticker that says this, PETA. I heart PETA. What's PETA?
A terrible word.
People for eating tasty animals. Let's just say that this guy is a fan of PETA.
What about ASPCA?
There we go.
Okay, yeah, sure. He's a fan of some charitable animal rights organization, right? What's that tell you?
He likes animals.
He likes animals. So let's say I find the PETA or whatever sticker on the neighbor's car. Does that raise or lower the hypothesis that he's the one killing all these birds?
I would say that rules it out.
You think that rules it out?
And if you like PETA, you're probably not shooting birds.
Who's a hunter? You're a hunter? Would you consider yourself kind of like conservationist? Like, would you think it's a bad thing in the government and we should probably donate money to not have white-tailed deer eradicated?
Well, I think it's a bad thing for the government to do anything.
Well,
In that case, I mean, I would say that a person who likes PETA probably isn't shooting swallows in their friends.
yeah, probably someone who likes PETA, yeah. Let's just say it's, what was it?
SPCA or ASPCA.
Okay. If it's not so extreme as PETA, but it's just some sort of like pro-nature group or pro-animal rights group, does that mean he has to be vegetarian and anti-killing animals?
No, especially if it's an invasive species.
Right, which, ever seen a starling?
Oh my gosh. Yeah.
Starlings were actually brought over from I think he's a New Yorker. He brought him into New York from England because he's a fan of Shakespeare, and Shakespeare talks about starlings a lot, and so he brought him over pretty recently, and then they've just taken over everything. So it's actually in Oklahoma, you can actually shoot starlings on site, even in like your own backyard, get a pellet gun or something. Just massacre them. Okay, so it's not necessarily. I would say it doesn't completely rule it out. Let's say it's not PETA. Let's say it's like just some animal organization. It doesn't rule it out, but it does lower that probability. And it lowers it pretty significantly, right? Because if somebody's a big bleeding heart animal person, they're probably not going to be, I mean, I'm talking a lot of birds I'm finding, right? They're probably not going to be the ones killing all of them. So it might even get close to ruling it out. Yeah. Okay. And now, what time is it, by the way? We got 11:45, right? Or 45, right?
Yeah.
Man, my brain. Okay. We'll finish this up. Okay. So we've got that. It's going to lower the probability of H1, raise the probability of H2 and H3 a little bit. The no hootings kind of lowered the owl hypothesis a little bit. Nice going. That looks cool. What do you have in your classes? Okay. Somebody find me a piece of evidence that would at least rule something out conclusively. What sort of evidence would that be?
Neighbor moves away.
Yeah, and the birds are still dying.
Your neighbor moves away. Okay, so let's say after a few days, the neighbor leaves, maybe moves away, maybe goes on vacation, and birds are still dying. I think that that is enough, probably. Although you could probably make some weird case that it's not, maybe the neighbor's sneaking back at night to kill him. Let's just say that we know that's not.
And it's a gated community. He lost his code.
Yeah, exactly.
When he was leaving the other night, after he left his house, caught on fire.
Oh.
That makes sense.
Let's say he dies. Yeah.
Yeah.
He dies.
Let's not have killed him.
That would rule out.
Now we know he killed him.
That would completely rule out H1. That he's the sole person or sole thing responsible for this. I guess it's technically possible though that he had an accomplice.
Oh my God.
It's a whole conspiracy.
Right.
A bird conspiracy.
What about like house, like bringing in simplicity that it.
How about he dies and someone else moves into his house?
Exactly, yeah. That's
If you have that and another, it makes you.
that's great, yeah. We're gonna talk about that a lot more. But so that's really good insight. What I was just saying was maybe he had an accomplice, so this isn't completely ruled out. But then you also brought up Occam's razor, which if we have to save this theory by making it so complicated, just get rid of it, right?
That's true.
Technically, you don't deductively rule it out. Okay, but here's the point of all of these. You're seeing how you draw predictions from theories, and how testing involves drawing predictions, looking around from data, and then seeing if that data obtains or doesn't obtain. If it's successful, if the theory is successful or if it's unsuccessful, right? Make sense? That's how testing works. And it works the same for predictions too. If I make a prediction, and then I know, let's say, if I make a prediction 1, and I know that that prediction 1, if it's true, will give me prediction 2, and prediction 2 doesn't happen, then prediction 1 doesn't happen, right? Again, that's if there's a deductive relationship. This 100% applies this, right? I'll start class next time by talking, but here's two sort of limits. If a hypothesis entails some data, and the data doesn't happen, then the hypothesis is false. It's disconfirmed to the maximal amount, completely ruled out. Now, we are almost never in the position to do this, as you've seen here. It's always going to be probability. So there's lower levels of this. If a prediction H, let's say, raises the probability, I'm going to write it like this. This data, given our hypothesis, is greater than 50%. If H predicts even somewhat this data, and the data doesn't happen, then that decreases the probability of H. To what degree? What?
It depends on like how confident you were that it was.
But like between like 1 and 49%, maybe? Because it's not 0 and it's not 50.
What do you mean? What, between what? Wait, I'm confused on what you're saying.
Like, we could just give it a range. It decreases the probability to between 1% and 49%.
So that wouldn't necessarily work, right? So we wouldn't be able to like do some sort of mathematical thing to have between 1 and 49, because it's not just like the remainder left over. This is saying that the hypothesis predicts some data, and let's just say it makes the data 80% likely, so that if the hypothesis is true, D would happen 80% of the time, or with 80% confidence. Now, D doesn't happen. I don't see how it follows from that H is only 20% probable, right? Complicated. This clearly tells us that probability is doing something beyond mere mathematics and statistics. This is weird. Overlapping, but different. So I don't exactly know how to say what is the quantity of this confirmation, but it does decrease it in proportion, or as a function of how likely it predicted it. How much it raised up the data's probability from before, right? So if it makes it 80%, that's actually good evidence that H isn't true, right? If you don't find D. But let's say it only makes it 60%. Is that a strong evidence? No, because it's a weaker prediction. Like, well, if H is true, maybe this will happen. There's a slight chance that it will happen. But it didn't happen, so that doesn't seem like a knockout argument, right? But if it's 99%, if H was true, then D is going to happen, and D doesn't happen, that's a pretty good argument against H, right? So there are the degrees of this sort of thing. And you have to say things like, in proportion to how likely H predicted the data, right? And that's why it gets complicated. All right, any questions?
So, were you saying that you don't know how mathematically to find the probability of your original prediction, but that's just kind of arbitrary?
I don't know how to symbolically give mathematical or numerical quantities to any of this stuff.
Okay,
Because-
so it's like an intuitive thing.
Yes,
But
this
that
is
seems more likely
intuitive.
than not. Or that doesn't seem very likely.
Yeah, like all this, we clearly know there are degrees of confirmation, degrees of disconfirmation. The limits are 100% disconfirmed, you rule it out, and 0%, which I guess 100% would be totally confirmed deductively. 0% would be completely disconfirmed, ruled out, right? But there's degrees within that. How do you mathematically, symbolically model those? Can you assign them numerical quantities? Interesting question. I do not know. People try. There's always problems. I could give you a system for doing it. It's still not very clear. Yeah. And that's, if anyone's interested in philosophy, you want to work on this, hey, be the first one to invent a logic for this. It's called confirmation theory. Any other questions? Okay, I'll see you later.